Hi, welcome. So I'm just going to give you a quick video as an introduction to planes. So we've talked about three-dimensional planes a little bit, but not really enough to dive into their equations and things. So I just want to go through some information about planes so that you have it and you can start thinking about sort of how they work. So I've already inserted some images here of some planes we're going to look at. Specifically, we're just going to look at like the XY, XZ, and YZ planes. So I'm just going to give you a little bit of reminders about these things, and we'll go through them, and then we'll give some more information. So this first graph I have here is the XY plane. It's only in the X and Y axes. There's no Z values. So in the XY plane, we say the Z values are 0. So any point on this plane is going to have a Z value of 0. And this means the equation for this plane is z equals 0. These are all of the points with the property that z equals 0, so we have z equals 0 as the equation. So if you think about like two-dimensional space and you have like x equals 0 would be the y-axis, right? So you could think about x equals 0 would be the vertical line here on the y-axis, since all the x values are 0 there. And then the horizontal axis would be y equals 0 because all of the y values are 0 on that line. So just a comment, this is sort of similar. The xy plane, we have z equals 0. So if we were to think about another plane sort of parallel to this one, so you can think about taking this plane and moving it up and down here, like up on the z-axis or down on the z-axis, parallel planes would have the form z equals a constant. So it would look like parallel planes. We'd have z equals some constant c. So you can imagine z equals 3 would be a plane at z equals 3. All of the z values are 3, but the x and y values can be anything. Okay, so just to get us used to this process, I'm going to repeat it for the other types of planes. So next we have the xz plane. So if we are in the xz plane, here, all of the y values are 0. So any point on this plane has a y value of 0. And this means that the equation for this plane is y equals 0. That's sort of its defining feature, is that all the points have a 0 y value. So if we were to shift this plane sort of either toward the positive y-axis or back along the y-axis, we'd have a parallel plane. And this would have the form y equals some constant, let's say b. So it would have all of the y values are equal to some constant value, and then the x and z values can be anything they'd like. All right, you can probably see where this is going. We're just going to do it lastly for the yz plane. So in the yz plane, we have always x values of 0. So every point on the plane has an x component of 0, x coordinate of 0. And so this means that the equation for this plane, the yz plane, would be x equals 0, since all of the points on the plane have a x value of 0. Okay, and then parallel planes would be x equals a. So let me write that out. So you can imagine taking this plane and sort of moving it toward the positive x-axis or backward on the x-axis. And so any plane would have x values that are always a constant value, say a. Okay, so this is just meant to get us sort of orienting about planes and things. I want to do one quick example where we talk about a point being on different planes. So this isn't really like an example where I'm asking you to do anything. I'm just going to show you some stuff. So let's say we have the point 3, 4, 5, and I want to talk about which planes it's in. So this is going to lie on the planes. So let's think about like what sort of planes we could write going through these points. So really quickly, I'm going to insert a little image here so that I have some axes to work with. Okay. And so our point is like 3, 4, 5. So I could try to graph it, but I'm just going to go one component at a time. So first we could take the plane x equals 3. So this would be the plane that has all of the x values equal to 3. So if we draw a line at our x equals 3, you can imagine then a plane sort of going upward. I'll do my best to draw it. So this plane goes upward, and of course it could cut below the axis as well. Okay, so this is my plane. This is x equals 3. And so my point 3, 4, 5 is going to be on this plane because it has an x value of 3. And so this plane here, the one that I've drawn, this one is parallel to the YZ plane. So this is just to help you get oriented. We're just thinking this plane here, we've kind of taken the YZ plane and moved it along the x-axis until we're at x equals 3. Okay, I'm going to repeat this process for the other parts. So we could also have y equals 4 and z equals 5. And just to be like super clear, these things that I'm writing are equations of planes. They look really simple, right? They're just x equals, y equals, and z equals, but in 3 dimensions they represent planes. If you didn't know which dimension we were in, it might be confusing, but we're assuming we're in 3 dimensions here. Okay, so let's talk about these other planes. If we had y equals 4, I'm going to think about going 4 on the y-axis. And then I have a plane where all of the values are equal to that. So I can imagine going up and down into this axis. Let's see how well I can draw today. So here's my plane. It's not perfect, but hopefully that gets you the main idea. So this plane here is y equals 4. All of the y values are equal to 4 on this plane. And so this plane is going to be parallel to the xz plane. This is just to help you, again, get your brain oriented for how it's sort of facing in the space. So I think the xz plane isn't too hard to think about since you know the x and the z are here. And so you can imagine this plane sort of coming along parallel to that. Okay, lastly we have z equals 5. In my opinion, this is the hardest one to draw, so let's see how I do. So here the z value would always be equal to 5. So I sort of just need to imagine a plane floating up here in space at z equals 5. So maybe like the middle here represents z equals 5, and then my plane sits above it. So, I mean, hopefully you can kind of envision what's going on here. But this plane would then be parallel to the xy plane. So again, you can envision the xy plane sitting down here. That's the one that is actually graphed out on this particular set of coordinates. And then the z equals 5 plane sort of sits above that. Okay, so there we go. That's just some examples of planes we could talk about that like aren't just the xy, yz, and xz planes. So just some examples to get you starting to think about planes, and we'll wrap up this section by talking about equations of more complicated planes in the next video. Thanks so much for watching, and I will talk to you soon.